My name is Dave Flannigan. I'm an associate professor of chemical engineering and materials science at the University of Minnesota. My project title is Simultaneous Visualization of Charge Carrier and Lattice Dynamics with Ultrafast Electron Microscopy, and I received the Beckman Young Investigator Award in 2015. My research in general terms is centered around the development of new imaging technologies to study the fundamental behaviors of materials, especially at the atomic scale and in real time. Expanding on that a little bit, we focus on transmission electron microscopy, well known for high spatial resolution and high energy resolution, but the time resolution has been lacking. And what we do is essentially expand that time resolution down to the femtosecond scale, 10 to the minus 15 seconds. By doing that, we can understand what's happening at the atomic scale and in real time. We've started to pursue coherent energy carriers in materials. These are low-frequency acoustic phonons in materials. Now, these move at very high velocities, they have very small spatial scales, but they carry a majority of the energy in many types of materials. Being small, nanometer scale, being fast, picosecond, femtosecond, we need to develop imaging technologies that can access those spatial and temporal scales, and that's exactly what we've done. And it's really through the BYI funding that we've been able to do that and go down that particular path. I see many future directions for the research. One that I'm particularly excited about is taking the imaging technology that we've developed and advancing that directly to the atomic scale, the molecular scale, to actually see atomic scale processes, molecular scale processes happen in real time. Chemical transformations occur at the atomic scale. The movement of electrons and atoms occur at those scales, and they happen very quickly. I think it would be spectacular to image those processes directly in real space and time, and that's what we've begun to do now, seated by the BYI funding that we've received. I think the main way Dr. Beckman's contributions to science have driven innovation is through instrumentation development. Development of new instrumentation can lead to new discoveries in fundamental science and engineering as well. And I think it's through that avenue that his contributions have really driven and expanded innovation. The BYI Award has prepared me for continued success by giving me the freedom to explore high-risk projects in terms of things that may fail, but if successful, will lead to completely new paradigm shifts, new discoveries, and new innovations, and new ways of thinking about our world.